Hi, welcome back to Hello Agrarian channel. In this video, we are going to see solar constant. Since our life on the earth is totally dependent on the sun's energy, it is useful to quantify the how much of the energy reaches the top of the atmosphere. So it is called solar constant. We can define solar constant as amount of energy falling on the earth's surface per unit area per unit time. So we can define solar constant as an amount of energy falling on the top of the atmosphere in unit area and in unit time. Okay, so it is called solar constant. This solar constant first time estimated by Claude Paulet in 1838. Claude Paulet in 1838. He was the first person estimated solar constant in 1838. He also developed perheliometer. He also developed perheliometer in 1838. You see, the value of this solar constant varies year round because two factors. One is the earth rotation, and the second one is sunspot cycle. Okay, the first factor is the earth rotation and the second one is the sunspot cycle. You look at here, in our last video also we discussed this earth rotation. As we all know, our earth rotates on its own axis and revolves in an elliptical orbit around the sun. So suppose for example, so this is the sun and this is the earth. Okay, so our earth rotates on its own axis and it revolves in an elliptical orbit. So when the earth comes closer to the sun, that is called perihelion. So during this time, the distance between sun and earth is 147 million kilometer. Okay, so this perihelion occurs in January 3. It occurs in January 3. Okay, and another one is when the earth goes away from the sun, that is called aphelion. So during this time, the distance between sun and earth is about 152 million kilometer. So because of this, the solar constant value will vary. Okay, You see here, so our earth is in an elliptical orbit around the sun. In certain part of the time our earth come closer to the sun, that is called perihelion, and sometime the earth goes away from the sun, so that is called aphelion. So because of this, solar constant value will vary. Another factor is this sunspot cycle. Okay, so the sun output varies by 0.1 to 0.2 percentage during its 11 years of sunspot cycle. Normally this sunspot cycle occurs once in 11 years. Okay, once in 11 years the sunspot cycle vary. The first solar cycle observed in March 1735. The first solar cycle began in March 1755 and ended in June 1766. Okay, so the first solar cycle began in March 1755 and ended in June 1766. You see, our sun is a huge ball of electrically charged gas. So this charged gas moves, it produced more powerful magnetic field. So the first solar cycle began in March 1755 and ended in June 1766. Okay, and currently, so at this time we are in current solar cycle is 25th. Okay, so we are in now in 25th solar cycle. Okay, the current solar cycle is 25th solar cycle. It was begun in started in December 2019. Okay, so at present time we are in 25th solar cycle and it was started in December 2019 and it is estimated to end in 2030. Okay, during the solar cycle the sun emits lesser radiation, then it increase the peak, thereafter it decrease the emission. Okay, so around 5.5 years of the solar cycle it goes to peak, then it decline the emission power. Okay, so this is because of this also the solar constant value vary. Okay, so there are two factors. One is the earth rotation, that what we discussed over here, and the second one is sunspot cycle. So the sunspot cycle occurs once in 11 years. So now currently we are in 25th solar cycle. It was started in December 2019 and it is estimated to end in 2030. Okay, so I can delete this one. Next one is how to calculate this solar constant. So calculations of the solar constant. So for calculating this solar constant we need two primary information. One is the radiation is incident and perpendicular to the earth surface, and the second one is the mean distance between earth and sun. the radiation is incident on a perpendicular to the earth surface. Okay, and the second one is distance between the earth and sun. Okay, so these two information are required to calculate the solar constant. Okay, there are 4 steps involved to calculate this solar constant. The step 1 is list the known quantities. In this, power output of the sun, so that is equal to 3.86 into 10 to the power of 26 watts. Okay, so this much amount of energy released by the sun. The second one is that distance between the earth and sun. Distance between the earth and sun, that we already knows about 150 million kilometer, or you can say 1.5 into 10 to the power of 11 million. Okay, so by this way we can calculate the solar constant. Okay, in step 2, model the scenario using geometry. Step 2, model scenario using the geometry. Okay, so for this I can delete this one. Okay, so as light releases the surface of the sun, it begins to spread out uniformly through the spherical cell. So for an example, this is the sun and this is the earth. Okay, so the earth revolves around the sun in an elliptical orbit as light released from the surface of the sun, it spread out uniformly through the spherical cell. Okay, so the surface of the spherical cell is 4 by r squared. Okay, the surface area of the sphere. Okay, the surface area of a sphere is 4 by r squared, and the radius of the this radius of the sphere is equal to distance between sun and earth. Okay, the radius of this sphere is equal to the distance between sun and earth, that is 1.5 into 10 to the power of 11 million. Okay, so right now we discussed this 1.5 into 10 to the power of 11 million. Okay, and the power of the sun, okay, the power of the sun is 3. I can write over here. Okay, the power of the sun is 3.86 into 10 to the power of 26 watt. Okay. Then now we can write the equation. Solar constant equation is power output of the sun divided by 4 by R squared. Okay. So this value we can substitute. So this power of the output of the sun value is 3.86 into 10 to the power of 26 and 4 by the distance between earth and sun is 1.5 into 10 to the power of 11 square. Okay. So you will get 1366 watts per square meter. Even you can express in or 1.366 kilowatts per square meter. In terms of calorie, you can express in 1.94 calorie per square centimeter per minute. Okay. So this is called solar constant value. Okay. So solar constant value ultimately is 1366 watts per square meter. In terms of kilowatt, it is 1.366 kilowatts per square meter. In terms of calorie, it is 1.94 calorie per square centimeter per minute. Okay. So for an example, suppose this is the earth and this is the sun. Okay. The amount of solar radiation falling on the earth's surface, that means the top of the atmosphere, in a particular unit area. Okay, in a particular unit area. So that is equivalent to 1366 watts per square meter, or you can say 1.94 calorie per square meter per square centimeter per minute. Okay. So it is called solar constant value. I hope you all understand about this solar constant, how to calculate this solar constant. Next one is albedo. Albedo means the proportion of light that is reflected by a given surface. As we know that sun emits a short wave radiation. Once reach on the surface, the soil gets heated up first, that is conduction process take place. Once soil got heats up, then it emits in a long wave radiation. Okay. So this is commonly held in our soil. First the sun emits short wave radiation and ground emits long wave radiation, because our ground is a radiation body. Okay. In some case, this short wave radiation reflected as a short wave radiation itself without changing any its quality, that is called albedo. Okay. The reflection of the same radiation without changing any its quality, so that is called albedo. Okay. So that is proportion of light that is reflected by a given surface. Okay. So it can be calculated as total scattered power upon total incident power. Okay. So out of incident power, how much power scattered without changing in its quality. Okay. So that is called albedo. Okay. So you can define more specifically that the ratio between the scattered, total scattered power to the total incident power. The earth albedo is 0.3. Earth albedo is generally taken to be 0.3, which means 30% of the sun rays that is reflected back to the atmosphere without changing any its quality. So the general albedo for the earth is 0.3. You see, the earth albedo varies daily and depend on various factors like latitude, cloudiness and even terrestrial influence also. Okay. So it may vary upon cloud, latitude and terrain influence. Okay. If there is thick clouds, then more reflection take place, because these clouds contains more ice crystals and these ice crystals reflect the radiation. Okay. So latitude also vary the albedo rate. Mid latitude produce more albedo as compared to equator region. So I have given albedo of common materials. You see, fresh asphalt has 0.04, bare soil is 0.17 and green grass 0.25. For desert sand it is 0.4, ocean ice 0.5 to 0.7 and for fresh snow it is 0.85. Okay. So among these we found the low value for bare soil, because the soil able to absorb more amount of radiation, that's why their reflection is low. So it is average value of bare soil is 0.17. Okay. Whereas fresh snow has 0.85. Okay. It is more among them, because the fresh snow actually white color and it reflects more as compared to absorption. Okay. So that's why their reflection, due to the more reflection, the albedo rate is more for fresh snow. Okay. Whereas you see green grass, again it is low value. Okay. That means it absorbs more amount of radiation. Similarly, the fresh asphalt sheet, okay, fresh asphalt sheet, it is 0.04. That means entire amount of solar radiation absorbed by this asphalt sheet, and that's why a house made up of asphalt sheets, so they feel more warm because it absorbs more amount of solar radiation and cause warm of that inside. Okay. So this is all about albedo. Okay, this is all about albedo. You see here, albedo has no unit because it is the ratio of power. Okay, so there is no unit for albedo. Okay, no unit for albedo because it is a ratio of power. Okay, so this is all about albedo. I hope you all understand about this solar constant and albedo what we discussed in this video. If you have any query, you can give your valuable comments in the chat box. Thank you.